Hello again. Let's do maybe two more examples. Let's say you have this differential equation. And you have initial conditions. Let's here we're not given a particular solution, so we just go one step at a time. Examine auxiliary equation and gives us r squared equal -1, so r is plus or minus I. So alpha is 0, beta is 1, in this kind of here, just there we compare. Okay, that gives us kind of the general solution for the homogeneous case, which is C1. E alpha is 0x cosine beta, which is 1x, C2 sine of x. So that makes it C1 cosine of x plus C2 sine of x. All right, let's now look into the particular solution. You see here, when you look at this, you know, the R, comparing it with what we have for the non-homogeneity, we see that we can proceed with maybe a constant times this exponential function, so we can proceed for particular solution. We can try this here. Because we don't have a polynomial there and stuff, right? So that tells us now we know that we need to try this into the differential equation. We don't have the first derivative there. And we have a function equals to the right-hand side, the non-homogeneity in this case. All right, so if you do the first and second derivative and replace it there, with the chain rule, we should get 122 times constant times this exponential function equals to this right-hand side. And that makes A to be 5/61 fraction here. So kind of we know now what the general solution is in terms of x. It's going to be this particular solution plus the general solution to the homogeneous case. So now we need to solve this IVP here using the initial conditions. Okay. Yeah, so if you try the first one, then that just gives us C1 to be -5/16. Yeah, so I wrote Y actually. Right. Z. So if we substitute here, then we should get this. All right, so that means now we need to find Z prime, which I tried here, and I got this here. Then I'm gonna use this the initial condition, and I should get, or you should get when you try it. Oh, yes. All right. Because that would give you the C2, and that would give you negative 55 or 61. Then you solve for C2, and you get 55 or 61. Okay, so that completes the picture. So I can maybe keep it in same page, or it's a little bit long, but just to show you the parts here. So that's the first part. That's the guess based on what we have. Then we found the general solution like the other problems. But now we move to solve the IVP by using the initial conditions. Then we found the constants. So let's just write it on the second page here, on the next page. All right. This other question, I think, maybe just to write the general or to write the particular and not solve. So let's see what I want to do here. Let's give me an example. Yeah, so I think, yeah, this one just to practice how to write that particular solution, because this could be, you may run into some tedious cases, especially if you're trying to get the first and second derivative and substitute on all that. So the goal here is to look in each one. It looks like this is the highest for the polynomials, and we have constants, so I will use the other form for the particular solution. And we need t power s, and r squared here minus 1 equals 0, r equal plus or minus 1, and um, for the e's, we have here 13. So SC equals 0. And the polynomial we will use based on the highest, to the highest is 2. So that means you need something like this. E, uh, 13t. Okay, let's say we want to look for the particular solution for this differential equation. We can see here that we have a mix of this term of exponential and these two terms with the trig function sine and cosine. So here we can use the idea of superposition principle and say that's f1 of t and this is of f2 of t. Then we can come up with their particular solutions. Let's say um, I do r squared minus 20r plus 101. Yeah, so try that. You get 400 minus b squared 400 minus 4 times AC, and you will get the R's, R1 or R2. In this case, they're complex and they're not matching. It's they're not matching these 12 for the beta right in the alpha. So, so the R for the alpha plus, for example, I beta is not a root. So check R for, let's just put R because you're going to check R1, R2 for R squared minus 20R plus 1 for 0. And you'll find that alpha plus I beta is not a root, which means you find that then you pick that S equals 0. As far as looking at just these two, we have a t here that is 1. We don't have a t there. So based on the revisited and determined coefficient method, then we can use a first degree polynomial. So yp, if I call this, I was going to call it trig, but let's just call it r. ypr a1 t plus a naught. So a sub 1 t plus a naught cosine beta, which is 12t here in the function. And we use b constants here. All right, so we get that, and that's good. But now we have we need another particular solution for the function to 11t, which let's call it particular solution for e. Because it's just the exponential, then we expect maybe some constant times that alpha is 11. Okay, so now it's the sum of these two based on that principle. So the particular solution for this equation is combining the two. Okay, thank you.